Next example, determine basis for null space of A given by this matrix is A is this 1 4 5 2 2 1 3 0 minus 1 3 2 2, and we have to find the basis for null space of A. So the null space of A is the solution space of the system, homogeneous system. Ax is equal to 0. We know that. And what is the Ax system? Ax is equal to 0. X means write the column matrix x1, x2, x3, x4. So this is the column matrix of order 4 by 1. Why it is 4 by 1? This matrix contains 4 rows, 1, 2, 3, and 4. So why? Because there in this matrix A there are 4 columns, 1, 2, 3, and 4. So what is the order of this matrix X? That is depend on the number of columns in the matrix A. So there are 4 columns, so take single column and 4 rows. So one single column and 4 rows. So 4 by 1. Its order is 4 by 1. Number of rows are 4 and number of column is 1. So number of rows depend on the column is always 1. But number of rows are what depend on the number of columns in the matrix A. So if there are 4 rows in this matrix, there are 4 rows. So take 4 columns. So we take 4 rows in the matrix, this column matrix. So, and we know that when the multiplication of these two matrices exist, if the number of columns in the matrix first is equal to number of rows in the second matrix. So there are 4 columns, so take 4 rows. Okay. If there are 5 columns, then take 5 rows. That is x1, x2, x3, x4, x5. If there are 3 rows, 3 columns, then take 3 rows as x1, x2, x3. So this is the column matrix X. So we have to solve this system and we have to find the solution of this system. So this system can be also written as this 1 into x1, that is 4x2 plus 5x3 plus 2x4 is equal to 0. Then 2x1 plus x2 plus 3x3 is equal to 0. And last equation is minus x1 plus 3x2 plus 2x2 2x3 plus 2x4 is equal to 0. So this system is in the matrix form. This system is in the equation form. Now we have to solve this system. So in the previous lecture, we already observed that how we can find a solution space of the system. That is how we can find the solutions space of the system. That is why to solve this system. So form the augmented matrix. We have to apply the Gauss elimination method. So form the augmented matrix and reduce the matrix to echelon form. But this is a homogeneous system. Either take the augmented matrix or the matrix of coefficient. Just if we take coefficient matrix A, then also we can solve the system by using Gauss elimination method. That is, take the augmented matrix or take the coefficient matrix A. So what is the big difference between coefficient matrix? This is the coefficient matrix 1 4 5 2. Then 1 1 3 0 1 1 3 0. That matrix coefficient matrix. This is the coefficient matrix 2 1 3 0. And then minus 1 3 2 2. This is the coefficient matrix. And if we have to take the augmented matrix, then write this matrix and write one more column, that 0 0 0. One more column 0 0 0. That is the augmented matrix. That is either take the coefficient matrix or augmented matrix in case of homogeneous system. Then we have to reduce this matrix to echelon form. So what is the application? We have to reduce this 2 to 0 and this minus 1 to 0. So write here first this matrix A and then apply these operations. So R2 minus 2 R1 and R3 plus R1. We have this matrix after this transformation. And then we have to reduce this minus 7 to 1. So minus 1 by 7 R2. No need to reduce this 7 to 1. Remain as it is. And then the application that R2 minus 7 R1 R2 R3 minus 7 R3 7 R2. And then we have this matrix. Okay. So reduce either this equal to 1 or don't reduce this equal to 1. So we have the same matrix here. And we have to reduce this. This is an echelon form. This is an echelon form. R1 minus 4 R2. R1 minus 4 R2. We have to reduce this 4 to 0. This is the actually reduced row echelon form. This is reduced row echelon form. So no need to form the reduced row echelon form. We just find the echelon form. And this is the reduced row echelon form. So either from this matrix or from this matrix, rewrite the equations. Rewrite the equations. So what do we have? Suppose this is the matrix, then we have x1 plus x3 minus 4 by 7 x4 is equal to 0. And then x2 plus x3 plus 4 by 7 x4 is equal to 0. And so this there are two equations and four unknowns. There are this system has two equations and four unknowns. So assign 4 minus 2, that is two unknowns. Assign two unknowns. So in order to solve the system, we have to assign two unknowns. So what are that? Suppose x3 is t and x4 is s. We can also take x4 as 7s. In order to remove this fractional, we can take x4 as 7s, or we can take x4 as s, and t and s are any real number. And so we obtain the solution. So from this we have the value of x2 as minus x3 minus 4 by 7 x4. So minus t minus 4 by 7 s as a x2, and x1 is what? Minus x3 plus 4 by 7 x4, that is minus t plus 4 by 7 s, that is substitute x2 x3 as t, x4 as s. And so we have the solution of the system as this: x1 is minus t 4 by 7 s, x2 as this, x3 as this, x4 as s. And so in the matrix form, this solution is x1 x2 x3 x4 is equal to, write this minus t plus 4 by 7 s minus t plus minus 4 by 7 s t s, that is, write the value of x1 x2 x3 x4, and then take t as common. We have the coefficient minus 1 1 0 as the column matrix, plus s 4 by 7 minus 4 by 7 1 0, there is no s, so 0 1. So these are the column two column matrix. Okay, so this is the solution. Actually, this is the linear combination of these two, and therefore the vectors form this column as a one single vector, as a row vector, minus 1 1 0, that is in round bracket minus 1 comma minus 1 comma 1, that is, write this as a one vector, minus 1 comma minus 1 comma 1 comma 0, and comma, and another vector is 4 by 7 comma, right, in round bracket as a row vector, minus 4 by 7 comma minus 4 by 7 comma 0 comma 1. And so these two forms the basis for null space of A, and therefore the basis for null space of A, actually this is the basis for solution space of this system, but the solution space of the system is equal to null space of the matrix A. And so the basis for null space of A is equal to these two elements form the set, right, in curly bracket, this two vector, minus 1 1 0 and 4 by 7 minus 4 by 7 0 1. Okay, so these two is element set is the basis for null space of A, and the dimension of null space of A is now 2. So the number of vectors in this null space are basis of null space are 2. There are two vectors, and so dimension of null space of A is 2, and therefore nullity of A is 2. So if the question is, this is the question that determines the basis for null space of A. Instead of this, the question is find nullity of A, then the same, we have to write the same answer. So what is the nullity of A? The matrix nullity of A. The question is, suppose determine the nullity of A. So what is the nullity of A? Is the dimension of null space of A. And in order to find the dimension of null space of A, we have to find the basis of null space of A. So find the basis for null space of A, then write the nullity dimension of null space of A, and then we say the nullity of A is 2. So in order to find nullity of the matrix, we have to find the basis for null space of A. And in order to find the rank of the matrix, we have to find the basis for either row space or column space. So if I have to find the row rank of the matrix and nullity of the matrix, then we have to find if the question is like this, find the rank and nullity of the matrix, means we have to find the basis for, in order to find rank of the matrix, we have to form the basis for row space of A or column space of A. And in order to find the nullity of the matrix A, we have to find the basis for null space of A. So first we will find the rank of the matrix. So we have to find the rank of this matrix. We have to find the basis for row space of this matrix. So reduce this matrix to echelon form. So the operations are R2 plus 3 R1. We have to reduce this minus 3 and 2 to 0. It is 1. So we have to reduce minus 3 and 2 to 1, 2 to 0. So the operation transformation are R2 plus 3r1, r3 minus 2r1. So we have this matrix. Okay. So while reducing these two to 0, these two elements are also reduced to 0. And so we have to now reduce this 5 to 1. So the application is 1 by 5 r2, 1 by 5 r2, or we can interchange the second row and third row. So that's depend on you. And therefore this echelon form, this form is different. This is not unique. Uh, this this echelon form depend on your calculation. So someone interchange these rows, two rows, to reduce this element 5 to 1. Interchange the third row and second row and third row. Okay. So that depend on your calculation. This is not a unique answer. This echelon form is not unique answer. This depend on your calculation. But the number of non-zero rows in echelon form are 2. So everyone has the echelon form in which the number of non-zero rows are 2. So this answer is unique, that the number of non-zero rows in echelon form are 2. So but that 2 rows are different. That depend on your calculation. So the operation is 1 by 5 r2. We have this, and then we have to reduce this 1 to 0. So the operation is r3 minus r2. While reducing this to 0, we have all the entries in the last row are 0, and so this is an echelon form. No need to find reduced row echelon form. In order to write the dimension of basis of column space, you have to reduce the matrix to reduced row echelon form. So this is the echelon form. This is the echelon form. Or in order to reduce the matrix to reduced row echelon form, the application is what? R1 minus 2 R2. So we have to reduce this 2 to 0, and therefore this column number 1 and column number 3rd contains leading 1, and so the other than 1, all the elements in the column number 1 and column number 3 are 0. So this is the reduced row echelon form. Actually, we have to write the either echelon form or reduced row echelon form in order to write the basis for row space of A. And therefore actually the column space or row space both are here where to write. So write this is an echelon form, and then what is the basis for row space of A? That is write this first row as a first row as a first vector, and the second row as a second vector, 0 0 1 2 minus 2. Okay, and then write 1 minus 2 2 3 1 as the first vector, or 1 minus 2 0 minus 1 3. Write this vector as a first vector, or 1 minus 2 2 3 1. So this is the basis for row space of A. In order to write basis for row space of A, we have to reduce the matrix to echelon form. No need of this reduced row echelon form. So from row echelon form, the number of non-zero rows form the basis of row space of A. So write the basis for row space of A, and then the rank of A is what? The dimension of row space of A is 2, and therefore rank of A is also 2. Or in order to find rank of the matrix, we have to we also find the dimension of column space of A. So in order to find the dimension of column space of A, we have to reduce this matrix to echelon, reduced row echelon form. And so column number 1 and 3rd contains leading 1, and therefore what is the basis for column space of A? Write this 1 minus 3 2 as the first column, and this 2 minus 1 5 as the second column, third column as the second vector. And so the this set contains these two columns, 1 minus 3 2 and the 2 minus 1 5. So these two vectors forms the basis for column space of A. And again the rank dimension of column space of A is 2, and therefore rank of A is 2. So in order to find rank of A is 2, we have to either find the basis for row space or column space, one of them. So write either basis for column space or row space. No need to write both the basis. So next is we have to find the nullity of the matrix A. So in order to find the nullity of the matrix A, we have to find the dimension of solution space of the system Ax is equal to 0. So what is the system? Ax is equal to 0. So what is the rank of this? What is the order of this matrix? This X matrix. So there are 5 columns, 1, 2, 3, 4, and 5. So take x1, x2, x3, x4, x5 as the 5 rows. And then this is the system. Now we have to solve this system, and we have to form the we have to write the solution space of this system. So we have to reduce this matrix to echelon form, this matrix to echelon form. So we have to reduce this matrix to echelon form, reduce this take this matrix as suppose A, this matrix as A, and then we have to reduce this matrix to echelon form. So already we have the echelon form. This is an echelon form of the matrix. So write here this matrix as in echelon form. So rewrite the equation. After obtaining echelon form, we have to write either obtain the reduced row echelon form or echelon form. So in order to solve the system, so rewrite the equation. What we have: x1 minus 2x2 minus x4 plus 3x5 is equal to 0 is the first equation. Then x3 plus 2x4 minus 2x5 is equal to 0 is the second equation. So the system has 2 equations and 5 unknowns. So assign 5 minus 2, that is 3 unknowns, and we had to assign 3 unknowns. So obviously we assign the x2 as t, x4 as s, x5 as r. So x3, x4, x5. So x3, don't assign all these x3, x4, x5, because if we observe, in order to find x3, we have to assign x4 and x5. But in order to assign find x1, we have to assign we have the value of x3 already, so we assign x2 and x4. So we assign x2 as t, x4 as s, and x5 as r. So don't assign x3, x4, and x5. So assign x4, x2, x4, and x5. So this is depend on the this equation. So we have to assign 3 unknowns out of the 5 unknowns: x1, x2, x3, x4, x5. So in this example, if you observe the last equation, then in order to find x3, we have to assign x4 and x5. And so don't assign x3, x4, x5. Assign x2, x4, and x5. Or either x1, x1, x4, and x5. x1, x4, and x5. So don't assign x3, x4, x5. So where t, s, and r belongs to r, capital R, any real number. These are any real number. Then we obtain x3 from this. X3 as minus 2x4 plus 5 plus 2x5. Substitute the value of x4 and x5. So we have x2 as x3 as minus 2s plus 2r, and we have x1 as 2x2 plus x4 minus 3x5. Substitute the values. We have x1 as 2t plus s minus 3s, 3r. x2 is t, x3 is this, x4 is this, and s, and x5 as r. So equivalently, we write this solution in the matrix form: x1, x2, x3, x4, x5. That is, we write the values of x1 like this, First write the values of x1 as this, x2, x3, x4, and then write this as a linear combination of these two. So here we have the linear combination of these three: t plus s plus r. So what is the t? 2, 1, 0, 0, 0. Then what are the coefficient of s? 1, 1, 1, 0. Then minus 2, 1, and 0. And what are the coefficient of r? Minus 3, 0, 2, then 0 and 1. Okay. So we have the solution in the matrix form, and therefore the basis for null space of A, actually solution space of A, the system X is equal to 0. So the basis for null space of A form these as a 3 vectors: 2, 1, write in round bracket 2, 1, 0, 0, 0, 2, 1, 0, 0, 0. The second vector, the second column as second vector 1, 0, minus 2, 1, 0, and the third column as the third vector minus 3, 0, 2, 0, 1. And this set, right in curly bracket. So this is the basis for null space of A. And so this basis for null space of A, actually this is the basis for solution space of the system Ax is equal to 0. And this is the basis for null space of the matrix A. And there are 3 vectors in this basis. And so we know that the dimension of dimension of any vector space is the number of elements in its basis. So the basis for null space of A contains 3 vectors, and so dimension of null space of A is 3. And the dimension of null space of A is called nullity of A. So nullity of A is 3. So this is the problem. And if you observe what is the rank of the matrix, rank of A is 2, and nullity of the matrix A is 5. And if you add these two, rank plus nullity, then it is equal to number of columns in the matrix. There are 3 rows, but there are 5 columns. So addition of this rank of A plus nullity of A is equal to number of columns in the matrix, and this is the dimension theorem for matrix, or is called rank nullity theorem for matrix. So what is that theorem? If A is a matrix with n columns, if the matrix A has n columns, then rank of A plus nullity of A is equal to n. That is, what is the theorem? Rank nullity theorem for matrix, that rank of A plus nullity of A is equal to number of columns in the matrix A. So this is the rank nullity theorem, and we verify the rank nullity theorem for this example. So this matrix A has a rank 2 and nullity 3, and this matrix has 5 columns. So rank of A plus nullity of A is equal to 5, that is number of columns in the matrix. So this is the rank nullity theorem, very famous theorem, rank nullity theorem, or is called dimension theorem for matrices. So we will see the remaining examples of this topic in the next lecture now. So